A mug, your phone, maybe a rock. What's your gut tell you it's made of? Probably tiny little solid balls, right? Particles.
Yeah, that's the intuitive picture.
And the space around it, empty.
Right. But what if that common sense picture, the one we all sort of grew up with, is fundamentally, well, incomplete?
Okay.
The stack of sources we have for this deep dive suggests a view of reality that's, let's just say, far more revolutionary.
So not tiny balls. What are we talking about then?
That's really the core of it. Our mission here is to pull out the most important nuggets from these materials. We're exploring this really powerful idea that the universe isn't built from fundamental bits at all. It suggests reality made not of particles, but of fields and, well, patterns.
Fields and patterns. Wow. Okay. That's a total flip from how we usually think about the world. No more imagining little marbles bouncing around.
Pretty much. Because these sources, they paint a picture where the universe is fundamentally more like a vibrating system.
A vibrating system. Okay.
Precisely. And this perspective, it often builds from observations right down at the atomic level. You might recall from, previous deep dives, or maybe it's a new idea for you, that electrons within atoms don't just zoom around randomly. They settle into very specific, stable states.
States that aren't like little planets orbiting?
Exactly. They're best described not as little balls, but as standing waves.
Standing waves, like on a guitar string.
That's a great analogy. Think of notes on a guitar string that resonate just right. Only certain frequencies can form a stable wave pattern.
And all the other possible ways it could wiggle.
They interfere with themselves and just cancel out. Poof, gone.
Right, like noise canceling itself out, leaving only the pure tone. Okay, I get that for electrons in atoms.
Exactly. Now, the truly radical jump these sources make is proposing that this principle isn't unique to electrons stuck in atoms. They argue this isn't some special case. It's the underlying rule for the entire physical world.
Wait, the whole universe, governed by this idea of only stable patterns surviving.
That's the profound implication these sources are drawing out. Yeah.
Wow.
And the theoretical framework that really underpins this view is quantum field theory, QFT.
QFT, right. Heard of it, but what's the gist in this context?
The gist is, it suggests the universe isn't ultimately composed of particles. At the bottom, it's fundamental fields. These fields permeate all of space-time. Think of an electron field, a photon field, a quark field, one for every particle type we know.
Fields everywhere, like an invisible fluid.
Sources describe it more like a quiescent ocean that's everywhere, just waiting.
Okay, so instead of little balls floating in empty space, we have these vast invisible oceans of potential. Is that the right word?
Potential is a really good way to put it. These fields aren't stuff you can grab, not in the usual sense. They're more like the stage, the medium upon which all the action happens.
So the electron field is where electrons come from?
Yes, exactly. The electron field is the potential for electrons to exist. The photon field is the potential for light, and so on.
All right. If the universe is fundamentally made of fields, then what is a particle in this picture? What's an electron if it's not a tiny ball in its field?
This is where the shift happens, and it gets really interesting. The sources define a particle like an electron or a photon, not as a fundamental thing itself, but as a localized vibrating excitation within its corresponding field.
An excitation, a vibration.
Yeah, think of it like a tiny, stable, standing wave pattern in that field.
So an electron isn't a little bit of the electron field, but a specific wiggle in the electron field, a pattern that holds itself together.
Precisely, that's it. An electron is a quantized, stable vibration in the electron field. A photon, that's a quantized, stable vibration in the electromagnetic field. A quark is a quantized, stable vibration in the quark field. Same principle.
Okay, hold on. You used the word quantized there. What does that mean again, practically?
Great question. When we say quantized, it means this vibration, this excitation, can only exist with very specific discrete amounts of energy and momentum, like steps on a ladder. You can be on step 1 or step 2 or step 3, but not somewhere smoothly in between.
Ah, okay. Discrete packets.
Exactly. And this explains why all electrons, for instance, are absolutely identical everywhere in the universe.
Because they're all the same rung on the ladder, the same allowed vibration.
They are all the exact same type of stable, quantized vibration in the electron field. Yes.
Got it. So all electrons are the same because they're the same note or harmonic being played on the electron field.
Exactly right.
Yeah.
And this also explains why particles have these fundamental properties, like mass and charge.
How so?
Well, these aren't properties of some tiny hard bit. They're determined by the nature of the field itself and the specific energy, the frequency of that stable standing wave.
So the mass comes from the wave pattern.
Yes. The sources explicitly state that the mass of a particle is simply the energy of its fundamental stable vibration. It's directly linked by Einstein's famous EMC where.
EMC2 applies to the vibration itself.
Right, mass is energy, and this energy comes from the stable music, you could say, being played on the field.
That's a profound connection. Okay, so we have fields. Particles are stable, quantized vibrations in those fields. How does this scale up? How do we get from these fundamental wiggles to everything we actually see and interact with? Atoms, molecules, this table right here.
Right, because that's the key, isn't it? This framework handles complexity beautifully. The individual particles are just the first level of stable patterns. The universe builds complexity using these patterns as ingredients.
Like combining musical notes into chords, you mentioned earlier.
Very much like that. A really good example is protons and neutrons, the bits inside atomic nuclei. The sources explain they aren't simple fundamental particles themselves. They're stable, complex arrangements of constituent standing waves.
Constituent waves.
Yeah.
Meaning
Meaning a proton, for instance, is a specific combination of 3 quark vibrations, 2 up quarks, 1 down quark, sort of held together by gluon vibrations. Gluons are another type of field excitation from the strong force field.
So it's not 3 little quark balls glued together. It's a stable, complex pattern of different vibrations interacting.
Exactly that. It's described in the sources as a stable, self-contained composite standing wave.
Wow.
They even use this really vivid analogy of it being a tiny, intricate chord.
A chord.
Yeah, its stability comes from this specific combination of vibrations forming a resonant harmony, a pattern that holds together that doesn't just dissipate or cancel itself out.
A tiny musical chord made of waves. That's a wild image to picture at the heart of every atom. Really shifts things.
It is. And the process just keeps scaling up. Take atoms themselves. As we sort of touched on, atoms are stable systems where electron standing waves, those are the familiar orbitals from chemistry, are arranged around that nucleus as a chord.
Okay, so the orbitals are electron waves settling into stable patterns around the nucleus pattern.
Precisely. And then, when atoms bond to form molecules, their electron wave patterns overlap and interfere.
Like ripples merging on a pond? Is that a fair way to think about it?
It is, but they don't just wash over each other. They settle into new, larger, stable patterns. These are called molecular orbitals.
Molecular orbitals.
So a chemical bond isn't like a tiny physical hook or spring. It's defined in the sources as a stable, lower energy standing wave pattern that now encompasses multiple nuclei.
Lower energy means more stable.
Generally, yes. Systems tend to settle into the lowest energy state available, so molecules form because that shared wave pattern is more stable, lower energy than the separate atoms. The sources present molecules as the next level of resonant harmonies the universe allows.
Okay, waves within waves, chords within chords, harmonies building on harmonies. I think I'm following the logic. But what about that rock I mentioned, or this table? They feel absolute, undeniably solid. How can that possibly be true if everything is just vibrations and patterns? This feels like the most counterintuitive part. Where does solidity come from?
You're hitting on the key challenge to our everyday intuition, absolutely. And the sources tackle it directly. A solid object isn't solid because it's made of tiny, hard bits packed together. No, it's solid because it's a vast, stable collection of these molecular standing waves, all locked into a persistent structure, like in a crystal lattice for many solids.
So the table isn't solid because it's made of hard atoms banging against each other?
Not fundamentally, no. The sensation of solidity isn't about particles hitting each other like tiny billiard balls. It's explained by the incredible stability and the resulting repulsive force between these nested electron wave patterns.
Nested electron wave patterns, meaning the electron clouds of the atoms.
Essentially, yes. The electron waves of all the atoms in the table form a huge, stable collective pattern. When you push on the table, you're not pushing hard finger bits against hard table bits.
I'm pushing my fingers. Wave patterns against the table's wave patterns. Is that it?
Precisely. Your finger is also a collection of stable wave patterns,
right?
Electrons in your molecules. And the table is a much larger, incredibly stable collection. The immense resistance you feel when you push, that's the energy required to significantly disrupt those incredibly stable, nested standing wave patterns in the table. They push back, or rather resist deformation, because breaking that stable pattern takes a lot of energy.
So solidity is essentially the powerful resistance of stable wave patterns to being disrupted or overlapped by other wave patterns.
That's the takeaway from these sources.
Yeah.
It's described as a large-scale interference effect. The patterns fiercely resist destructive interference from outside forces trying to push into their space.
Wow. Okay.
Right.
That actually makes a strange kind of sense. Takes a minute to absorb, though. So let's zoom all the way out now. If this picture holds, what's the ultimate view of the universe that emerges from this whole field perspective?
Well, the sources synthesize it into this really breathtaking view. The entire physical universe is basically a colossal, self-interacting system of quantum fields.
Colossal. Okay.
And the laws of physics, they aren't rules for how little particles move through space. They are the rules for how these fundamental fields vibrate, how they interact, how they combine and resonate.
The universe is one giant, vibrating, interacting system running according to certain rules of harmony.
You could definitely say that, yes.
Okay.
And the particles and structures we observe, from the smallest quark pattern inside a proton to the largest galaxy supercluster pattern, they are not the fundamental building blocks themselves. They are, in a very real sense, the survivors.
The survivors. Yeah.
They are the specific stable frequencies, the resonant harmonics, complex chords, that can actually sustain themselves in this cosmic system without being instantly erased by destructive interference.
Huh. It sounds almost like the universe is constantly trying out every possible note or vibration, but only the ones that resonate stably actually stick around and become the reality we see. Everything else just cancels out instantly.
That's a fantastic way to put it, yes. And the sources offer this final, really powerful analogy to try and grasp it. The universe is like an infinitely complex musical instrument.
An instrument.
An instrument. And what we perceive as physical reality, the stars, the planets, the trees, the feeling of solidity in this table that is its symphony.
The specific music that can be played stably on this cosmic instrument, allowed notes and chords.
Exactly. Planets, stars, trees, even people in this view. We are all beautiful and intricate standing waves. Complex, stable patterns that have emerged from the silent, formless potential of the underlying quantum fields.
And the space in between things. You said the fields are everywhere, so space isn't an empty void then.
The sources really emphasize this point strongly. The void of space is not empty, it is filled with the potential for all vibrations. It's brimming with these fields.
Wow.
The matter we observe, the physical forms we interact with, they are simply the music that is currently being played on this vast underlying instrument.
So just to sum this all up, based on these sources we've looked at, we've journeyed from a picture of the universe built from tiny solid balls to a picture where reality itself, at its most fundamental level, is about patterns of vibration and resonance in underlying fields.
That's the core shift in perspective, yes.
And listening to this, you've basically just gotten a shortcut to understanding a pretty cutting-edge, though maybe still debated, view of the universe's fundamental nature.
It's definitely a profound shift. It challenges our deepest intuitions about what it even means for something to be real or solid.
Absolutely. And building on that, and on the source's conclusion, if everything we experience, everything that is fundamentally vibration and potential within this vast, complex cosmic instrument, it makes you wonder what other kinds of music might be possible, what other kinds of stable patterns or resonant harmonies could exist in the universe's symphony. Ones we haven't yet observed, or maybe ones we can't even perceive with our current senses or tools.
That's the lingering question, isn't it? What else is playing?
Something to think about.